it's a very important um, you know aspect to keep in mind, that when we are talking about any data system, any data store system, I want to get the data as close to the latest as possible. I want to be able to identify when something went wrong and fix the data with relative ease. I want to make sure that the system should give me enough tools, levers, checks and balances to ensure that my data is replicated at the right time. And if there are some gaps, I need to know about that. So there are two solutions for that. One is automatic, the other one is manual. So, and all of these are designed to ensure that the data consistency across multiple nodes is taken care of. Let's see how. The first one is hinted handoff. The second option is read repair, and there are two flavors to it, blocking and non-blocking. And the third one is no tool repair, which is an anti-entropy op. It's important to bring out that hinted handoff is an automatic feature. Read repair, both flavors are automatic feature. Cassandra will take care that is. Whereas in case of the last one, which is anti-entropy op, or what do we call it as no tool repair, right, that is a manual activity. And we need to execute this manual activity every once in a while. I know, I said every once in a while. What do you mean every once in a while? There's got to be some quantification around that. I'm going to come to that, right, at an opportune moment where we understand a very interesting aspect which influences this quantification of once in a while. And that concept is called tombstones, right? So we're not going to talk about tombstones just yet. For now, let's take it at face value to say that every 7 days, at an average once a week, 7 days, you must run the manual activity. Now, before we get into each one of these, or get into the node tool repair, let's first understand what these automatic features are before we discuss manual. So the first one is hinted handoff. Very interesting name, isn't it? Right. What it basically means is once the request is received by the coordinator, right, and it is at, let's say, consistency level that it can attain. So for instance, replication factor 3, consistency level quorum. So it can proceed with the reads and writes. And if the coordinator finds that a node is down, or it is offline, or it does not acknowledge a write operation that it gave, then what happens is the coordinator stores the data locally on the disk on behalf of the downed node. So every node in Cassandra gets a unique ID. It's a giant big UUID. So the file name will be UUID hyphen the NTP hyphen 1. And if there are lots of data that it's storing on behalf of the downed node, then it can go to hyphen 2, hyphen 3 and all of that. So the whole idea is the coordinator will temporarily store the data on behalf of the downed node, which otherwise it was planning to send to that node. And with the live replica nodes, it can attain the consistency level. This is called as a hint. So naturally, you can imagine that if I use the round robin policy from the client and different nodes are contacted, and it so happens that all the data that I intend to insert for the partition, it includes node number 4, which is unavailable, then naturally the different nodes, all the nodes that acted as a coordinator, will start to carry hints, physical files that are stored. Now the obvious problem with that model is you need to make sure that these data that it's storing can be delivered to the node as quickly as possible. Otherwise, the disk utilization is going to increase. It is just additional overhead for the coordinator to manage this additional data that it's not responsible for in many ways, right? So what was happening is we cannot really allow the hints to build up over, infinitely. So Cassandra community decided that, well, we need to put some checks and balances in here. And the first check is the maximum amount of time that a hint will be stored is 3 hours. That's a default time. You can increase it if you like. Right? You can also have some other flags which controls the amount of hint in terms of size that you can store on the disk. Please note, storing a hint does not contribute to the consistency level. That means imagine if two nodes were down, N3 and N4, and I operate at consistency level quorum. So can I send one replica node to N2 and store two hints, or rather one hint, let's say, and say that, hey, I attained consistency level quorum? No. Storing hints does not contribute towards the consistency level. So obviously, coming back to the point of the duration of data storage, so a node can be down for, let's say, 3 hours, and all the coordinators will continue to store the data for up to 3 hours. And if the node does not come up within 3 hours, no further hints will be stored. Absolutely no questions about that. So is it possible that you can increase that from 3 hours to, let's say, a day? Sure. Is the data volume going to increase? Yes, absolutely. So what happens is, let us assume that yes, indeed, the node temporarily went down because of some perhaps network outage and all that. And soon the network was restored and the node came back up again. So now what happened is, once the node came back up again, it, guess what, started gossiping. And because of that gossiping, the coordinator or the set of coordinators, plural, came to know, oh, welcome back, node 4. Good to see you. Hey, by the way, I got some data for you. I'm going to send that across to you. Now consider a situation, folks, that my incoming data velocity, let's say, was pretty high. So a lot of data was stored in all these coordinators. And when N4 came back up again, and the moment these nodes realized that, hey, N4 is up, all of these nodes can start transmitting the data. All of these nodes will start transmitting the data. And suddenly N4, who's just recovering from a crash perhaps, right, gets this humongous load of data, right, coming in from all these coordinator nodes. Guess what? It might so decide, nah, I think I'm going to go back down again. Right? So there's got to be a way in which you can control the amount of data that is coming in to avoid the node which is just recovering from getting overwhelmed. So you can control the stream megabytes per second. So you can control how much data you can stream. So if there is only one coordinator, it will get the whole bandwidth. I think the default value is, I think, 16 or something like that, Mbps. And if there are two nodes, it's going to get split in 8 and 8. If there are multiple, then it will be the total allowable bandwidth divided by the number of coordinators who are looking to transmit the data. Right? That's how the bandwidth will be shared, to make sure that the node which is coming up does not get overwhelmed. Pretty smart. All of these things are pretty much out of the box. We don't have to worry about it. It just comes. So continuing on, right, this is to kind of conclude the conversation on hinted handoff with a visual representation. So there you go. Once the node is up and running, the coordinator will say, oh, welcome back. And that is how it's going to send the hint across to that particular node. And do note that these hints are physical files which reside on a particular given node, coordinator node, that is.